What's up, everybody? Welcome back to the channel. Welcome back to our deep dive.
Huh.
Today, we're focusing on something pretty awesome, SpaceX's Raptor engines. You're really into SpaceX, so we're going to unpack how these engines have evolved over time,
Right.
especially from Raptor 1 to the latest Raptor 3.
Yeah.
Why does this matter? Well, these engines are basically the heart of Starship.
Mm-hmm.
And Starship is meant to take us to Mars and beyond.
Yeah, what's really cool about the Raptors is that they're not just like a bigger version of older engines.
Right.
SpaceX is completely changing the game here.
Okay.
They're focused on reusability and efficiency in a way we haven't really seen before.
Yeah. They're not just about building a bigger rocket.
Nope.
They're trying to reinvent how we do space travel.
Exactly.
Okay, so let's start with Raptor 1, the OG, the one that kicked it all off.
Yep.
It first fired up back in 2019.
That's right.
What made it such a game changer right from the start?
Well, Raptor 1 was the first full-flow staged combustion engine to use cryogenic methane and liquid oxygen. Most rockets use kerosene-based fuels, so this was a pretty bold move by SpaceX.
Okay, got to stop you right there.
Sure.
For those of us who aren't rocket scientists, what exactly is full-flow staged combustion?
Yeah, good question.
And why is cryogenic methane? That's just super cold methane, right? It's such a big deal.
You got it.
Okay.
So think of full-flow stage combustion like a super efficient engine.
Okay.
It's designed to squeeze every ounce of power out of the fuel,
Right.
which is super important for those long hauls to Mars.
Makes sense.
And as for cryogenic methane, keeping it super cold helps with storage and performance.
Okay.
But the really interesting thing about methane is that unlike kerosene, we can actually produce it on Mars.
Wait, so you're telling me future Martian colonists could be brewing rocket fuel alongside their morning coffee?
Haha, essentially. Yeah.
Sign me up. Seriously, though, that's amazing.
It is pretty cool.
It ties in perfectly with SpaceX's long-term goal of establishing a permanent base on Mars, right?
Exactly. They want to just visit. They want to stay. It's a crucial part of their bigger vision.
Okay.
Now, Raptor 1 achieved a thrust of around 200 tons,
Okay.
which is impressive. But the main focus was proving that this whole full-flow staged combustion thing worked with methane.
Right.
It was about laying the groundwork.
Okay, so Raptor 1 was all about we're going to do things differently and it's going to work.
Yeah.
But then comes Raptor 2, which is where the power really starts to ramp up.
Absolutely. Raptor 2 hit almost 230 tons of thrust.
Wow.
That extra power was crucial for testing Starship prototypes at higher altitudes and getting them ready for orbit.
Mm-hmm.
But it wasn't just about raw power.
Right.
There were other improvements, too.
Here's where it gets really interesting for you.
Oh.
Remember how you're always talking about how important production efficiency is to SpaceX?
Mm-hmm.
Well, with Raptor 2, they managed to simplify the design with fewer parts.
Yes.
What's the benefit of that?
Fewer parts means faster and cheaper production.
Right.
That's critical when you're trying to build hundreds of engines for a fleet of starships.
Right. It's like saying, okay, we've got a working prototype.
Yeah.
Now let's make it something we can actually build on a massive scale.
Exactly.
So what exactly was improved from Raptor 1 to Raptor 2?
Well, thrust increased from 200 to almost 230 tons.
Okay.
The design was simplified with fewer parts for faster and cheaper production.
Makes sense.
And there were also improvements to the combustion chamber and nozzle for better performance and efficiency.
Makes sense.
Yeah.
So Raptor 2 was all about taking that initial concept and turning it into something practical and scalable.
Yes.
And then, bam, enter Raptor 3. They basically cranked everything up to 11 with this one, right?
Raptor 3 is where SpaceX started to seriously push the boundaries of performance and durability.
Okay.
Especially with deep space missions in mind, we're talking over 250 tons of thrust, making it the most powerful Raptor yet.
Okay, that's a lot of power.
Yeah.
But wasn't there a concern that this much power would be difficult to control? Especially during landing. I mean, you're essentially trying to land a skyscraper, right?
That's a great question, and you're right, control is paramount.
Yeah.
But remember, Raptor 3 isn't just about brute force, it's also about durability.
Right.
Which means they focused heavily on advanced thermal management systems and even tougher materials.
Okay.
These upgrades allow the engine to handle longer burns and the insane conditions of space travel, particularly the intense heat.
Wait, so you're saying they basically gave this super powerful engine a heat shield?
You could say that.
What exactly do they improve from the last variant?
Okay, well, thrust increased again from 230 tons to over 250 tons.
Got it.
They used more durable materials to withstand the harsh conditions of deep space.
Okay.
And they introduced even more advanced thermal management systems, enabling longer burns and greater reusability.
So it's not just about reaching Mars.
Right.
It's about making those longer journeys possible and coming back in one piece.
Exactly. It's about making space travel more sustainable and cost-effective for those epic deep space voyages.
Right.
Reusability is key. It's not like you can pull over at a cosmic gas station for repairs.
Uh-huh. Very true. This is all starting to make a lot of sense. They're really committed to making Mars a regular destination, not just a one-off trip.
Right, they're playing the long game, and the evolution of the Raptor engines clearly shows their dedication to this goal.
Yeah.
They're constantly innovating and pushing the limits of what's possible, and they're doing it incredibly fast.
It's pretty mind-blowing to see how quickly these advancements in rocket technology are happening.
I know, right?
It really makes you wonder, what's next?
That's the big question, isn't it? I mean, if SpaceX can achieve this much in just a few years,
Right.
imagine what the next generation of Raptor engines will look like,
Yeah.
and what incredible things they'll let us do in space.
Right. It's almost impossible to even imagine.
It really does make you think, doesn't it? It seems like just yesterday we were celebrating Falcon 9's first landing.
I know, right?
And now we're talking about giant reusable spacecraft,
Crazy.
powered by engines that can fire for hours on end.
It's like science fiction becoming reality right before our eyes.
I know, it's wild.
Speaking of which, remember that sci-fi movie you love where they're mining asteroids?
Yeah.
Well, what if Raptor engines make that possible someday? I mean, these engines are basically designed for deep space, right?
That's absolutely right.
Yeah.
The implications of this technology go way beyond Mars.
Okay.
We could be talking about missions to the outer solar system, setting up scientific outposts on distant moons, or, yeah, maybe even mining those asteroids for precious resources.
Whoa.
It's a whole new era of space exploration.
Okay, before my head explodes from all the possibilities, let's take a step back and recap what we've learned about these incredible engines.
Sounds good.
Yeah.
So, we started with Raptor 1, the Trailblazer, which proved that the whole concept of full flow stage combustion with methane could actually work.
Right.
It was a risky move by SpaceX, but they pulled it off.
Yeah. Then we had Raptor 2, which was all about boosting the power, streamlining the design, and making it possible to build these engines on a massive scale.
Yeah.
It was the practical workhorse that got Starship closer to orbit.
And finally, we have Raptor 3.
Yes.
The current powerhouse pushing the limits of power and endurance, designed for deep space, able to handle longer burns, and built to withstand the harsh conditions of traveling beyond Earth's orbit.
So each generation builds on the one before it, constantly evolving and improving.
That's right.
It's a testament to SpaceX's iterative approach to engineering.
Absolutely.
But I have to ask, with all this talk about how awesome these engines are,
Yeah,
were there any challenges they had to overcome during development?
of course. Innovation never comes easy.
Right.
One of the biggest challenges they face, especially with Raptor 2, is combustion instability.
Oh, really?
Yeah, imagine trying to control a controlled explosion.
That does not sound easy.
It's not.
Yeah.
That's essentially what's happening inside a rocket engine.
Yeah, that sounds pretty intense. So how did they solve it?
Well, they had to get really creative with the design of the injector,
Okay.
which is the part that mixes the fuel and oxidizer.
Right.
They had to find the perfect balance of pressure flow rate and even the shape of the injector elements to make sure the combustion process was stable and efficient.
So it's not just about slapping on bigger parts to get more power.
Yeah, right.
It's about understanding the complex dynamics of combustion and engineering solutions at a microscopic level.
Exactly.
That's incredible.
It is, and that's why SpaceX puts so much emphasis on testing.
Mhm.
They're constantly pushing these engines to their limits, gathering data and refining their designs.
Right.
It's a constant cycle of trial and error learning and improvement.
You know, it's interesting how this all ties back to something you mentioned earlier.
What's that?
SpaceX's goal of making space travel sustainable and affordable.
Exactly. The innovations we've talked about with the Raptor engines, reusability, efficiency, high thrust,
Yeah.
they're all aimed at reducing the cost of getting to space.
Makes sense.
And that's the real game changer, isn't it?
Right. It used to be that only governments and billionaires could even dream of going to space.
I know.
But SpaceX is trying to change that.
Yeah.
They want to make space accessible to everyone.
And that accessibility is what will unlock the true potential of space exploration for humanity.
I like that.
Imagine a future where scientists, entrepreneurs, artists, even you and I could experience space travel.
Wow.
That's the future that Raptor engines are helping to create.
That's pretty mind-blowing, to be honest. So
Yeah.
we've gone from these incredible engines to deep space exploration to the future of humanity.
Still a lot to take in.
This is way more than just a deep dive into some rocket parts.
Right.
I think our listeners probably out there mind-blown by all this, trying to wrap their head around it all.
I wouldn't be surprised. It's a lot to process for sure, but it's also incredibly exciting.
Yeah.
And I think it leads us to a very important question. What does all this mean for us? For our listener who's deeply interested in SpaceX, for the future of humanity, for all of us?
That's a big question, and one that deserves a little more time to ponder. So we've gone from these super powerful engines to Mars colonization, to the future of humanity as a spacefaring species.
It really has.
It's been quite a journey.
But I think what's most exciting is that we're just at the beginning of this journey.
Right.
SpaceX is pushing the boundaries every day, and who knows what they'll come up with next.
Okay, so let's talk about the what's next.
Okay.
Raptor engines have come so far in such a short time, it's hard to even imagine what future iterations might look like.
Right. It's like trying to predict the smartphone of 2030 back in 2010.
Right.
We probably wouldn't have even come close.
Exactly. But we can speculate a little, right?
Sure.
Based on what we've seen with the evolution of Raptor 1, 2, and 3, what are some areas where we might see improvements in the future?
Well, one area where SpaceX is constantly pushing the envelope is thrust. Each generation of Raptor has been more powerful than the last, so it's safe to assume they'll keep looking for ways to squeeze out even more power.
So even bigger engines with more thrust. Where does it end? Will we ever hit a limit?
There are always limits, of course.
Right.
But the beauty of engineering is finding ways to push past those limits.
I see.
Maybe they'll discover new materials that can withstand even higher temperatures and pressures, allowing for even more powerful combustion.
Okay.
Or maybe they'll explore completely new engine designs, something we haven't even thought of yet.
Like something straight out of science fiction.
Exactly. Maybe they'll figure out how to harness some new form of energy, something more efficient than chemical propellants.
Whoa.
Who knows? Maybe we'll see fusion-powered Raptor engines someday.
Okay, now you're really blowing my mind.
Ooh.
But seriously, it's clear that SpaceX isn't afraid to think big and take risks.
Yeah.
They're always looking for that next breakthrough, and I have a feeling they'll find it.
They probably will. And for you, our listener, this is where it gets really personal. Think about this as SpaceX continues to push the boundaries of space travel. What role do you envision yourself playing in this unfolding story?
Yeah. Would you be among the first to set foot on Mars? Or maybe you'll be designing habitats for future Martian colonists or building the next generation of spaceships.
It's an incredible time to be alive, to be witnessing this new era of exploration and discovery.
It really is.
And the most exciting part is that it's just the beginning.
So to our listener who's obviously fascinated by all of this, we leave you with this.
Okay.
The future of space travel is wide open.
It is.
It's a future we're all writing together. Keep exploring, keep questioning, and keep dreaming big. Because as we've learned today, the sky is definitely not the limit.